Good afternoon, everybody. My name is Talbot Brooks, and I'm the president of the Geospatial Information and Technology Association. We are the premier geospatial education society for the industry, and are just tickled to death to be able to bring today's webinar to you from Mr. Jack Hild. His webinar will be titled The 4 Eras of Commercial Satellite Imagery. The presentation reviews the evolution of capabilities delivered by electro-optical satellite imagery from the perspective of resolution, accuracy, speed of delivery, and content. Each era has had a profound impact on the value satellite imagery can have on a wide variety of user missions. With numerous examples from the U.S. commercial satellite imagery, the presentation will provide attendees with a good understanding of the many improvements since the launch of ICONOS in 1999, as well as a glimpse into the future of Earth observation. Mr. Hild has presented several variations on this, and it's really a landmark work, and we're tickled to death that he's able to join us. As an independent consultant, Mr. Hild advises clients on geospatial strategies and geospatial education. While his focus on the defense and intelligence sectors, he is currently serving as an appointment to the National Geospatial Advisory Committee, where he serves as an advisor on domestic geospatial policy. Mr. Hild also serves as co-chair of the United States Geospatial Intelligence Foundation Working Group, where he organizes geospatial workshops around the world. Prior to founding his consulting practice, Hild was vice president at Digital Globe, serving as Chief Information Officer and as VP of Defense and Intelligence Strategy. Jack spent 30 years at the National Geospatial Intelligence Agency, where he's held numerous senior executive positions, including Deputy Director of Source Operations and NGA's Assistant Chief Information Officer. After September 11, 2001's attacks, Hild crafted NGA's Homeland Security mission, including major policy reviews and the development and implementation of geospatial data and tradecraft initiatives. Throughout his career, Hild supported major crisis actions as a cartographer and executive leader. He was also a principal in NGA's international initiatives, crafting bilateral production and analysis strategies with many nations, and by providing executive oversight during the creation and implementation of the multinational geospatial co-production program. Hild is the recipient of numerous awards, including the NGA's Distinguished Civilian Award and the Norwegian Defense Medal. That's a heck of a resume there, Jack. We're, again, just absolutely thrilled to have you with us. I'd like to give everybody a few rules of the road. Please make sure that you mute your telephones. Otherwise, we get lots of feedback and uninteresting things bleeding into today's webinar. And we also ask that you please visit www.gita.org and take a moment to join GITA. It's through memberships like yours that we're able to make these types of educational opportunities available. So please do take a moment and consider joining. We think it's money and time well spent, especially given the quality educational opportunities that we're able to provide. So without further ado, Christina, reader, you probably want to mute your camera. But without further ado, Jack, it's all yours.
Thanks a lot, Talbot. I appreciate the introduction. Obviously, nobody does that without great teams, and I have to admit that the teams that I worked with at NGA and also at Digital Globe were just some of the finest folks in the industry. So it's been a real honor for me to do that, and it's an honor to join you here this afternoon. Like Kevin said, one of my current hats is serving as the chair of a USGIF working group, and like GITA, we are focused on education. And so the genesis of this briefing, as Talbot mentioned, is in performing educational workshops around the world. And while we focus mostly on the defense and intelligence sectors, we have done this. We've reached out commercially and done this with a couple of other associations focused on geospatial information. And so the briefing today is really through that lens of 35 plus years in the industry, and simply sharing some observations about commercial satellite imagery that I've been exposed to as I've gone through my career. Before I really get started into the four eras, really the summary of this is looking at that electro-optical satellite story, going all the way back to the launch of Landsat, and then taking a look at where we may be going in the future. I'd like to start with a couple of slides that sort of set the context. The slide that you see now was given to me by a guy named Brian Rutledge. Brian was the #2 guy at the European Union Satellite Center many years ago. And for years, I've briefed this slide as two specific themes. One was the proliferation of sensors in the highest resolution. You see that grouping of many satellites in the sub-meter or approaching the sub-meter resolution. And then the other theme was the movement towards higher and higher resolution. And I think that I'm changing the way I'm looking at this now. As I think over the next 5 years and what this slide will show with all of the small sat sensors that we expect to be up there. The way I expect I will brief this in the future is more, again, more and more satellites, because clearly that's what's going to happen with the small sats. But I think that there are certain companies that are now finding their niche in terms of resolution. And my best example of that is one that's not even shown on the slide, the Rapid Eye constellation currently being flown by Blackbridge out of Canada. Those guys have settled in at about 5-meter resolution and have announced a upgrade to their constellation towards 2020, where they're going to put up almost the same thing, focused on about that 5-meter resolution. They are going to put a 1-meter panchromatic sensor on board, but they seem to be very comfortable in that 5-meter resolution range. And I think that we will continue to see companies find their niche and kind of stick to it and do it very well. 3 more slides to just give you a sense of the landscape with commercial satellite imagery today. Here you see really the 2 leaders in the highest resolution, Airbus and Digital Globe. And one of the things that I always say about this slide is if your mindset about commercial satellite imagery is in the 2006 or 7 time frame, you really have a very different view than what reality is today. There's really been an explosion with the launches of both the Digital Globe satellites as well as the Airbus satellites, but you get a sense of the amount of collection that can be performed by those vehicles. Looking also at the Spy constellation and the Rapid Eye constellation, you also see a significant growth, especially with the launch of Rapid Eye. And when you put them all together, you'll notice I changed the vertical scale on the slide. We're approaching being able to obtain 3 times the land mass of the Earth every single month. And when you think about, we're all hearing the big data discussions within the geospatial industries. This is really big data, and it's exciting to see this amount of content being made available to a wide range of users. So that leads me to look at the 4 eras and how that context will help explain where we've come from and where we're going. First era being resolution. And if you look at this chart, you can see back in '72 when Landsat 1 was launched, it was launched at an 80-meter resolution. And then periodic improvements to Landsat, they settled pretty quickly on the 30-meter resolution, which is where they are today. Spot has been a big player in the 5 to 10-meter resolution for many, many years. Iconis was the first to break the 1-meter barrier in 1999, and then you can see the entire digital globe / GeoEye constellation settling in that less than 1 meter resolution category, with Pleiades, two Pleiades vehicles showing up in 11 and 12. And then finally, looking at Worldview 3, which was just launched this August. Many of you probably know that that NOAA governs the resolution for U.S. satellites, and for many, many years the restriction was at 0.5 meters. They reduced that this year to 0.25 meters, and Worldview 3 is currently flying at 0.33. So that kind of gives you a sense of where things have gone with respect to resolution. I know that everyone on in the webinar probably knows what different resolutions look like, but I've always found it educational to just kind of do a review. So what you're seeing now is a 30-meter resolution, typically what you would see from a Landsat image. Moving down to 15 meters, which would be a pan-sharpened Landsat image, down to 10, and to 5, typically where we would be with Spot and Rapid Eye. 2.5 meter down to 0.5 meter, which is representative of the U.S. commercial satellite industry, and obviously you can see that that's the Colosseum in Rome in the lower right-hand corner. Finally, with the 0.3 meter resolution, which is what we're going to see with Worldview 3. Why is this important? Certainly you can start to see things at 0.3 meters that you couldn't see with a 1 meter imagery. When you look at the differentiation between cars and trucks, you can count individual people. Obviously can't identify people yet, but certainly counting folks. Likewise, you can look at things like roof condition. You see in this particular image the deterioration of the shingles on the house that's circled in blue. Likewise, looking at potholes even. And so from an infrastructure maintenance, I know that the insurance industry is always interested in looking at roof composition and things like that from an insurance standpoint, especially in fire-prone areas. So we're seeing a lot of new applications as the resolution gets better and better. When I look at where we are and where we've come with resolution, every company that's building satellites could build a satellite that will provide better resolution than what we have today. However, when I look at this in terms of that first era of commercial satellite imagery, we're about done. We will see slight improvements, I'm sure, and when I look at the cost versus those improvements in resolution, it starts to get really expensive to go from where we are today to something that is significantly better. And obviously for the U.S. companies, you're restricted by what the federal government will allow. So while everybody will kind of tweak things just a little bit, I think we're about at the end of this era. Which brings us to accuracy. In a lot of ways, the accuracy is following the same trend. As I was growing up in the NGA organization, quite often the only measure of accuracy that was really important was would the imagery meet the requirements for making a certain scale map. If it was good enough to do a 1 to 50,000 map, it was good enough. And obviously, with the proliferation of GPS and the fact that everybody has a sensor in their telephone these days, having that blinking dot not be on the image in its correct place is a huge disadvantage if you don't have the accuracies to the level that meets your GPS accuracies. And so we've seen a lot of changes here. We've also seen the improvements in the imagery, and this is just one diagram that will illustrate the kinds of improvements we've seen as we've moved from Landsat to that first generation of 1-meter birds to the current generation of much higher resolution. The imaging processing software has gotten a lot better. The ability to position the birds when they take a picture has gotten a lot better. We still can do better with accuracy, and certainly every company that is flying a satellite, every company that is doing any kind of image processing will continue to try to torture another 1/10 of a meter of accuracy out of their imagery. But we're also getting close to being done with this era as well as the era of resolution. And again, as we see large imagery mosaics, new uses potentially coming in, we're going to see folks continue to try to squeeze just every bit of accuracy out of the image. But the facts are we've gotten really, really good at this, and there's not a lot of room for improvement left. Moving on to the third era, and this is about where I think we are today, and that is speed. Every time I do this presentation, I use a slide that looks like this, and I ask the audience to raise their hand if they still get imagery in the mail. And inevitably, hands go up. And certainly for large amounts of imagery, it still makes sense in a lot of ways to put a server in the mail and send that out. But as you can see from this chart, the ability to get imagery, to take the imagery, to get it from space to the ground, and then get it from the ground to a user, the times have come down dramatically in the last few years. One of the reasons that that's happened is a company called KSAT. It stands for Kongsberg Satellite Services. And KSAT is a public-private enterprise made up of the Norwegian defense company called Kongsberg and the Norwegian Space Agency. And what KSAT has done, they built a couple of ground stations in Tromsø, Norway, which is the furthest reaches of the of mainland Norway, and were very successful there and established a fairly large satellite ground station in Spitsbergen. Fly to Oslo, fly 2 hours north to Tromsø, fly another 2 hours north, and you're in Longyearbyen. And what they can do from Longyearbyen is see every polar orbiting satellite for every orbit, and that's a huge benefit in being able to uplink instructions and downlink imagery for anyone who is using their services. And virtually all of the commercial imaging satellites, as well as NASA and NOAA, take advantage of their services. And in fact, so successful that they opened up another ground station in Troll, Antarctica. It's not quite as far south as Longyearbyen is north, so they can generally 13 of 14, 12 of 13 orbits they can see from Troll. And then again, building a successful business, they've also put in 7 mid-latitude stations, and the net result of what they have done, especially over the last 4 or 5 years, 95% of the landmass is available to image and download and get back to a satellite operator within 20 minutes, and often quite better than that. This is just a couple of shots to give you a sense of what the landscape looks like. This is flying into Spitsbergen. This is just a small shot of the ground station that sits on a plateau just north of Longyearbyen. And that is me in the yellow jacket with a guy named Oyvind Bergene, who's the former director of the Norwegian mapping organization, as well as Doug McGovern, who is the director of Innovision at NGA today. Moving south, this is where the location of the Troll ground station is, and this is a quick bird shot of what they have in Troll. Nowhere near as extensive as their ground stations are in Longyearbyen. However, the company between these two and the mid-latitude stations are managing about 200 individual satellites, which is a significant number. They work with comm satellites, the commercial radar satellites, as well as the EO, and then some of the NASA and NOAA satellites. So a significant capability. I've visited the northern spot. I haven't made it down to Troll yet, but what we've seen with the way the company operates is that they are very, very good at what they do and are working hard to get imagery from the satellite down to the ground and then back to the individual users as fast as they can. With that kind of speed, one of the things that Digital Globe did a couple of years ago was to look at the possibility of ortho-rectifying the daily take. And so for a month period, Digital Globe took every image that was received, ortho-rectified it, and posted it to a website. You see the bullet down there that says the average timeline was nearing 4 hours. And for me, that was a very significant event because, and while I will never advocate that users will completely migrate away from raw imagery, I do see a time in the future fairly close where the main building block for all of the value-added products will be an ortho-rectified image that is done in near real time from receipt from the satellite. I think that 2 hours starts to become a magical number. If timelines can reach 2 hours from the time the image is taken on the satellite until it's available as an ortho-rectified image to a user, I think that you start to really break into some new user communities who have very, very time-dominant missions to take care of. So really interesting to see how this will play out. Which brings me to this next slide, which I think is probably the most important slide in the briefing. For years, we have all of us who have been involved in some aspect of mapping, have followed almost the same process. We have a requirement, we collect an image, we do the mapping information, and then we send it out to a user community. And one of the things that I really loved about the NGA vision that happened a couple of years ago was their vision of having online on-demand access to content. My argument with that is that online on-demand access to 3-year-old data just doesn't get anybody excited. The expectation is that you will get real-time data or near real-time data, and I think that there are many applications across the world where that is important. And so when I look at the capacity that you saw in my early slides, the speed with which ortho-rectified imagery can be made available to a user, I think that it's really time for us to be thinking about real-time data maintenance. And as I've done some modeling of production timelines and so forth, I think not only do you get a much, much better geospatial database by doing that, I think you can do it actually cheaper than the old traditional sequential process. So it'll be interesting to see how all of that works. I've seen it work in practice in certain national special security events. where literally data, information, content, geospatial content is being radioed in from police and firemen on the scene, and the geospatial database being maintained and updated in real time. So I think that there are applications for this that are important, and I think that even the traditional make a map and it's good for 5 years communities will consider something that's more dynamic. Okay, going forward to content, this era started with the launch of Landsat 1 and continues today. The reason that I put this last, though, is because I think that it has a much longer future. We're at the end of the resolution and accuracy eras. We are approaching the end of the speed era, but I think that when you look at all of the different multispectral image capabilities of literally all of the companies that are putting satellites up today, the hyperspectral sensors that are flying on airplanes now and highly likely to be flying in space at some point in time, as well as LiDAR. I think that there is so much growth and so much opportunity in that realm that I think that we will be in this era for many years to come. Part of my my bachelor's work was as a coastal geomorphologist, and so bathymetry is always something that has interested me. When I was at NGA, I experienced a couple of remotely sensed efforts to calculate bathymetry that didn't go really well. And so when I sat down with the image scientists at Digital Globe, and they talked to me about the WorldView 2 8-band sensor and the possibility of capturing bathymetric information, I was very skeptical. And as a couple of years of working with both the image scientists at DG as well as image scientists throughout the community, my cynicism has disappeared, and I truly believe that this is a breakthrough that is going to be very useful to many in the maritime community. Being able to see down 30 meters with the level of accuracy that you see there, plus or minus 2 meters, has been demonstrated a number of times. Clearly, when you are in turbid water, you don't get those kinds of numbers. But you can get, even in somewhat turbid water, you can get some information. And so the value of this, with being able to image and calculate bathymetry in a shoreline area after a major storm has gone through, being able to pre-plan a typical bathymetric survey and potentially make decisions to not put a ship out are real advantages of this. And in the military side of things, being able to gather bathymetric information in denied areas is also a great benefit. So while I don't see this as replacing the traditional shipborne surveys, it is something that can add a lot of information and perhaps delay the need for a survey. The next 5 or 6 slides or so are just various combinations of the bands that will give you a sense of the content that is obtainable through the 8-band sensor. This one in particular, even though the focus is on bathymetry, one of the real values of this combination of bands is that it gives you excellent definition of the shoreline. So you can see more and more content, and certainly when you get to this point, being able to to get a sense of the vegetation and the bottom composition, very valuable to the nautical community. Another part of content, and again, this is using WorldView 2 and WorldView 3 examples, is with geology and mineralogy. In this particular one, looking at an image and identifying the signature for iron ore, which is what you see on the right-hand side. Certainly makes it easier to begin to identify it by using various spectral algorithms, and one of the things that sensor was designed to do. Likewise, here's another example with a true color image, combinations of bands with finally a actual mineral classification. And while I know that silica and calcite and those other minerals are really important, whenever I see this slide, I turn to the image scientists and ask them if they can find me gold. And of course, they all shake their head no, and I move on. Next, I'd like to just share a couple of images. This is the first WorldView 3 shortwave infrared image that was released. That's the true color image. That's seeing through the smoke and the haze with that sensor. This is just the band 8, which gives you a real understanding of the hot spots. Same here. And finally, this is just a composite of looking at the differences between smoke and clouds in a true color shot, and then taking advantage of the SWIR capabilities. You'll notice that the cloud is up in the upper right-hand corner of both images is still obscuring terrain, but all of the smoke has been cut through to be able to see exactly where the fire is, as well as being able to see, get a good rendition of the terrain. One of the other things that a lot of us are really excited about is something called CAVIS. Stands for Cloud, Aerosol, Vapor, Ice, and Snow. And if you think of this sensor as a sounding sensor, forward-looking of the image and calculating atmospheric disturbance and applying that to the image as it's taken. For years, we've always applied those kinds of corrections, but they've been more general numbers than a measured number. And CAVIS gives us the opportunity to apply a measured calculation for atmospheric distortion. And so these two slides give you a sense of how much better an image potentially can be by cutting through a lot of that haze. Some of the image scientists that I talk to believe that there are some reflectance products that will ultimately be produced from something like this. I'm still not quite convinced of that yet, but anything that gives that kind of clarity to an image is well worth it from my standpoint. Finally, on the spectral content, we've been in a mode, at least from my NGA experience, of show me there. We know where we want to look. I may be responsible for monitoring a port somewhere in the world, and so an image shows up. I look at the thing I'm supposed to look at and determine if there's anything important that has changed. Where I see multispectral imagery taking us is to be able to ask the question or make the statement of show me where. In this particular case, show me where significant development has happened in a city. Or even more so, let me put a bounding box on a feature and have software search through a large image archive to show me where there are things that look like this or this. Those are some of the opportunities that I see, and as image processing gets more and more mature, as the archives from all of the companies who are collecting imagery continue to grow and grow, I think it's only going to be natural to find companies and individuals start to develop these kinds of search capabilities that will really help us understand and find things around the world. Finally, on content, I'd like to talk a little bit about temporal content. What you're going to see now are 25 images taken in one pass over London. And think of this as having it's not a video, but it's getting close. It's one shot about every 2 to 3 seconds. So I'm going to let this run without talking through it, and then I'll provide some other insight when we get to the end. If you've been to London, we're looking straight down on the London Eye. So that was 25 images in about a 2-minute collection period. If you're looking for things like patterns of life, I think that it's something that can help do that. I do believe that everyone who has seen this kind of capability, I'm geeky enough about satellites and all to be really excited about just seeing the capability, but seeing the uses are still eluding me a little bit. And I like to expose the capability to folks because I'm sure that there are a lot of folks who will have other ideas about how that might help them meet their particular missions. Next up, I just wanted to provide a real quick update. Calvin said I could do a 2-minute commercial, so this will be my 2-minute commercial. And it really is just to give an update on WorldView 3. Launched on 13 August. Excuse me. Successful launch. Everything is going as planned. You saw a couple of the images that have been taken. There's continued calibration will happen, and NGA in particular has a process that we go through to make sure that everything is working the way that we expect it to work, and that we're sure that the accuracies are exactly what they need to be. So that will continue on. I would expect that if you have access to the NGA enhanced fee contract, that the images will be available very soon in the first part of the year. Now, going back to the geeky side of things and looking at the temporal nature of content, I'll play that one more time. This is when WorldView 3 was launched. WorldView 1 was in position to take one of those time-sequenced images. And so what that clip that I just showed was WorldView 1 taking a very oblique shot of the launch of WorldView 3. And it's just a bright flame on a bunch of clouds for the most part, but I think it's still pretty cool. So getting into the so what. Back when Katrina hit, I was working at NGA, and a day or two after landfall in New Orleans, James Clacker, who was the director of NGA at the time, looked at us in one of the morning update meetings, and he said, I want people to be able to see their houses. I want people to be able to see their houses. And good staff officers that we all were, the boss said do something, and we all went off and did our best to make it happen. And in just a couple of days, both Digital Globe and Space Imaging at the time allowed public release of all of their imagery over Louisiana. We declassified some imagery. We had there were airplanes flying. There was a Predator flying. And we were able to do what Director Clapper said. We were able to let the public get into various websites and see if their house was still there. Fast forward to this image back in 2012. This is a town hall meeting after one of the fires in Fort Collins, Colorado. And it's exactly the same thing. All of these people have either been evacuated or are expecting that they are going to be evacuated. You can see the imagery up in the rear projection screen, and they are listening to one of the local officials explain the extent of the fire, and they truly are wondering if they can see their house. And so for me, the reason that I'm in this business and continue to just get excited about the future is to be able to help people who need the help that imagery and geospatial activities can provide. And when I look at the last decade, the commercial imagery explosion, 2005, I think Google Earth popped. GPS has enabled so many different applications. We've all, like I said before, we've all got them in our phone. The data and the content that the satellite navigation services are providing, that OpenStreetMap is providing, and even I'm seeing more and more cloud-sourced geospatial content being made available. So with all of those things, it is such a fabulous time to be part of this industry. It's clearly, at least from my perspective, an area that will continue to grow, and as more content is available, brilliant people like all of you guys who are professionals in this industry will continue to find innovative ways to use this and to help people see their houses. So I think that concludes my presentation, Talbot, and I think we've got a little bit of time for questions.
Jack, thank you. And again, I want to remind our audience to please post any questions they might have into the chat window, and I'll ask Jack. I wanted to pick up on a question I put to you at the last NGAC meeting. Given the huge leaps being made by satellite imaging, how do you suppose aerial photography and perhaps even the use of drones in many circumstances might be affected longer term? It seems kind of like there's a bit of a technology cost race going on here.
Oh, I think you're absolutely right, and obviously the drone issue is still a political issue as well as a air safety issue. I don't see, I still don't quite see that as being a major source for national mapping kinds of activities. I think that we're certainly going to see them for surveillance, law enforcement applications. I would imagine that state and local mapping organizations may find a use for them if they are accurate enough, and I think that that's still a ways off. I think that when I think about the drones, I also think about the small sats, and I think Planet Labs is expecting to have 130 satellites in orbit by the end of this year. So you see all of that kinds of all those kinds of sensors being launched. There will be a fallout at some point in time. I don't think that all of the experiments will work. I think that the expectation about accuracy, especially, is still spot on, and most of the small sat, most of the drones still aren't quite there with respect to the accuracy that I think that most state and local governments need. But go out 10 years and who knows?
Well, and I think the same question extends even a step further here. We have another one in kind of going back to the future with the ability to get higher and higher resolution ortho imagery. You can obviously grab stereo pairs and create DEMs. Where is that going? What kind of resolutions can we expect to come out of a stereo pair satellite-driven DEM in the future?
I saw some tests done, and Worldview 2 stereo pair was compared with a LiDAR over a section of Colorado, and I was truly shocked that the quality was as close as it was. I know Digital Globe is not thinking about offering a 1 meter DEM, and I don't think that it could stand up at scale, but in this particular case, a 1 meter DEM was created, and the point-by-point comparison to the LiDAR was amazingly close. That said, I'm a huge fan of LiDAR. I think that the sensor does some remarkable things. I certainly saw a lot of the work that was done with LiDAR, both over the U.S. and over Afghanistan, and I'm a huge fan of LiDAR. So I think maybe the future of stereo is a space-based LiDAR system.
That would be neat. Two related kind of questions from Steve. The quick turnaround time for imagery is very exciting, particularly with respect to emergency response. However, few folks in that community know how to ask for it or find it. How do you think that problem can be solved?
That, quite honestly, that problem is what caused the USGIF working group that I chair to be formed. So many times, even in the DOD, we found that there just wasn't understanding. If you didn't know the secret handshake, it was hard to figure out. I think that a combination of a couple of things. I think that for Digital Globe and being able to go through the NGA contract is one thing. However, often NGA's priorities don't necessarily match a state, and so it becomes hard to achieve those kind of timelines. I do know that if you have a .gov account, you can get access to one of the other programs that does the Earth rectification. And so that is a help. But I would say the other thing is reaching out to the individual companies. Certainly in crisis support, especially if it's a named crisis event by, and I've forgotten what there are a number of different organizations that will declare global events a crisis or not. You can count on virtually every satellite company to be chasing those. I know that Digital Globe does. I know Airbus does. To a slightly lesser degree, I think Rapid Eye does. And then the commercial radar guys as well. So all of the companies are going after crisis when they reach a certain threshold. So I would say just reaching out to them. They're certainly anxious to sell to whoever they can sell to. It'll be the thing that I've always heard from a lot of local governments is the question is, when is the price going to come down to the point where a local government can afford it? And I will say that the prices have come down significantly over that 10-year period. I didn't include any of those slides in my presentation, but it truly is remarkable about how far the prices have come down. But I know that there's still a hurdle for local governments.
And then lastly, Jack, you've alluded to the volumes of data that are coming down off these platforms, and I've personally had the opportunity to visit Paul Marin up in the Polar Geospatial Center and just see his collection of rooms and rooms of fireproof safes filled with hard drives archiving this stuff. Is perhaps part of this fourth era that we're going to bump into our ability to manage the data itself? And how do we start, as a geospatial community, pushing for some of the computing advances that need to get made in companion with our ability to collect imagery?
It's a good question, because all of the companies, Digital Globe, for example, based on the license that NOAA grants, has to maintain a copy of everything that they've ever collected. I don't think anyone has convinced Digital Globe, and I would say even this probably applies to the NGA community as well. Most of the studies that I've seen in looking backwards and trying to do research on the archive, while there's some great examples of where people have done some remarkable things with that, the amount of use is probably less than 1%. And so the struggle that both NGA and the companies are going to have is there really enough interest in the user community to make easy access to that full archive a priority. And so I think the thing that folks need to be thinking about is how to create that compelling story that will give the companies and give the government the incentive to go do that. I do think that what Landsat has done has been pretty remarkable, but I don't know how far they've gone back with everything. So I don't know if they've gone all the way back or not.
Well, Jack, that sums it up for the questions. On behalf of our audience and GITA, we want to extend our heartfelt thanks and again remind our listeners, please do visit gita.org and become a member. It's your membership, paid memberships, that help us make content like this available on a continuing basis. We look forward to having you all join us in our next webinar. Please keep an eye in your inbox, and we'll send out notice appropriately. And again, Jack, thanks a lot, and we wish you a very, very happy Thanksgiving.
Talbot, thank you very much. And just one comment to the rest of the audience. So many folks who are online are professionals in this industry, and I just want you all to know that what you're doing is special and important to the constituencies you serve, and you have my heartfelt thanks for what you do every day. So thanks again, Talbot, for the opportunity to speak today.
Hey, thank you, Jack. Happy Thanksgiving, everybody.
Yep.